Our project is fake news detection using hybrid AI approaches. Fake news spreads rapidly through social media and can create serious political and economic problems. Since manual fact checking is too slow, our objective is to build an AI system that can automatically classify news as real or fake. For this project, we use Hugging Face fake news dataset. Each sample contains a news title and article text with labels 0 for fake and 1 for real. The same dataset is used for all models to ensure a fair comparison. We compare three AI approaches. First, classical NLP using TF-IDF and logistic regression for speed. Second, distilled transformer model for better contextual understanding. And third, OpenAI GPT-4 prompt engineering for advanced reasoning. This helps us compare speed, accuracy, and reasoning capability. I will demonstrate the preprocessing and baseline model development stage. The main goal here is to prepare the dataset and build a classic machine learning baseline. For this, we use the fake news dataset from Hugging Face. Our task is to transform this raw text into a format suitable for machine learning classification. First, I load the dataset and inspect the train and test splits. Then I combine the title and article body into a single text field because both provides useful information for classification. After that, I perform EDA to understand class balance and article length distribution. Next, I preprocess the text. This includes converting text to lowercase, removing URLs, removing unnecessary characters, removing stop words, and limitating words. After preprocessing, I convert the clean text into TF-IDF vectors. I use both unigrams and bigrams so the model can capture individual words as well as short word combinations. Then I train three baseline classifiers: logistic regression, passive aggressive classifier, and multinomial naive bias. I evaluate their performance using accuracy, precision, recall, and F1 score. Based on the evaluation results, the best baseline model is the passive aggressive classifier, which achieves F1 score of 0.9778. After that, I analyze the best model further using the confusion matrix and the classification report. Finally, I save the trained model TF-IDF vectors and evaluation results.
In distilled fine-tuning, first we load all necessary Python libraries required for this project and define our global variables and training parameters. Then we load sample of 10,000 training and 3,000 testing articles to keep the training fast. And we also combine the article title and body into a single feature. Since computers only understand numbers, we use distilled tokenizer to convert our text into numerical sequences with the fixed length. So we use PyTorch data loaders to feed the data to the model in small batches. So this will prevent the RAM from overloading. Then we load a pre-trained distilled model and add the classification head. Then we train the model for two approaches to classify real and fake news. After training, we evaluate the model on 3,000 unseen test articles. The model achieved an accuracy of 98.4, precision of 99.5, recall of 97.6, and F1 score of 98.5. Finally, we save the fine-tuned model to the local disk. This allows us to deploy and use the trained model instantly in our web app without retraining.
This is the Microsoft AI Foundry portal, and from here we can create agents and deploy models. For our project, we deployed GPT 4.0 model. Here we are measuring how the LLM detect fake news with some prompt engineering strategies. Here we are establishing the connection between OpenAI model and our client application with OpenAI API key. And next we prepare a test sample with sample size 40 articles. And next we design the prompt with these three strategies. This is system message. to the LLM, and these are some examples that we are giving to the prompt. And the strategy, uh, if the strategy is zero shot, then use a prompt is like this with article. uh, and next we run each strategy over the sample, and finally we ended up with these F1 scores, 0.89 to chain of through, and 0.82 to zero shot, and 0.82 to few shot.
From the comparison, Distilbert performed best in accuracy, logistic regression was fastest, and GPT-4o was best for reasoning.
Let me show you the demo app we built. I will test it with 4 real examples. The first one I found it from a Sri Lankan news site. The baseline and Distilbert both said it was real, but the GPT-4 said it fake. This was a fake one I generated with AI. The base model said it real because it's written like a proper news article. The third one was a viral fake news post from social media. All three model caught it as fake. The final one, this was an official AP news report about the France heat wave, but the baseline said it fake. So the baseline model just looks for word patterns, and the Distilbert was smarter.
Thank you for listening to our presentation.